All right, guys. So first thing I want to talk about before we start is that we have a base number and we have an exponent number. So for example, something like this, base numbers can be like the 9 and this minus 10. The x can also be a base number, and then the exponent is like the 2, right? So combining like terms, when you have the same variables on these numbers, 9 minus 10. So basically what happens is that you're getting the 9 and the minus 10, and you're putting those together, and you end up with negative 1 x squared and then y. All right, this is combining like terms. Subtract 6w from 8w. So if I'm taking something from, it's kind of like a little flip. So let's put like a flip, because the 8w is going to go first, and then you're going to subtract 6w's from there. So if I have 8w's and I take away 6w's, I'm left with 2w's. So this is just basic combining like terms. Do not change common variables and exponents, right? Now, we're going to talk about product rule, is multiplying some stuff with exponents. Okay, if I have a base number with an exponent times a base number with the exponent, all right, that base number stays the same, but I'm going to get this exponent and I'm going to add this exponent. All right, and I'll explain what that means. So I have h squared times h to the 6. So basically, if I were to expand this, this is going to be h times h, all right, because there's 2 of them. And then I'm going to have 6 h's right here, h times h times h. All right, 1, 2, 3, 4, 5, 6, because that's what the exponent is. It's how many h's do you have. But instead of writing it like this, all right, this is the expanded version. We call this expand. All right, we don't want to do all the expanding. I just want to go ahead and follow this little rule. If I get that 2 plus 6, if I count them all total, then you'll notice is going to be 8. All right, all I'm doing is getting the 2 plus the 6, and that's it. All right. Now, when you're multiplying, all right, the base numbers is the a's. These, the regular numbers, negative 2 and 7, they're still multiplying. This is still saying multiplication. So negative 2 times 17 is negative 14. I have a 2, so remember, this is going to be like the 2 plus 3. So I'm going to have a to the 5, because you have 2 plus 3. Now right here, remember, there's a 1 and there's another 1. So what is 1 plus 1? B1 and B1 is going to be 1 plus 1 is going to be squared 2. So don't forget that you have those little ones. All right, so if we're multiplying, we're going to add up the exponents. Now, if you have 2 exponents, notice how we only have 1 base number and 2 exponents. Base number stays the same, and we're going to multiply. So if you have double exponent, they multiply. If you don't have double exponent, they don't multiply. So for example, right here we have x, and right here this is going to be 2 times 3. So that's going to be 6, right? Because what's happening is that the inside is being repeated by the outside. So basically it's like if we have x squared times x squared times x squared. You see how there's 3 of them? Because the outside says there's 3 of the insides. There's 3 x squareds. But this is xx, xx, xx. You see how we keep expanding them? But if we count them all up, it's going to be x to the 6. So we just do that at the very beginning. We don't have to expand. I just did this as an example. All right. So again, we're multiplying. There's a 1 right here in the front. I'm just going to put a 1 so I don't forget. Now I have some double exponents going on, so I can't even do anything until I get rid of these double exponents. Now this 2, it's going to double exponent with this one, and it's also going to distribute here. So the negative 2 gets a little squared on it. The m5 gets that little squared on it that we're multiplying. Now remember, there's nothing here, so it just goes. Now, if you want, you can put a little 1, and it'll be 1 times 2. Okay, if you want. Right now, we have negative 2 squared. We have, what is 5 times 2? 5 times 2 is 10. And then we still have to multiply that 1m3. So now we can multiply like we did before. What is negative 2 squared? That's going to be 4, positive 4. It's very, very complicated. m10 times 1m to the 3. All right, so where did this 4 come from? I came because if I put negative 2 squared, negative 2 times negative 2 is positive 4. And then right here, now I can multiply. What is 4 times 1? That's 4. And then I have m10 and m3. That's like this over here. So I'm going to add them. There's going to be m to the 13th power. All right, so you notice how they can get really complicated really easy. All right. Quotient rule. If you have a base with these, you're going to keep the base, and then you're going to subtract a minus b. All right. So 27 divided by 42. Now you can put these into the calculator and just reduce them. All right, let me show you. All right, so I do the fraction thing, alpha x. All right, push alpha in the x. 27 on top, 42 on the bottom. You get 9/14. All right, so I have a 9 on the top, 14 on the bottom. Now for this one, put a 1 right here. So I'm going to get x5 minus, and then x1. So what's 5 minus 1? X to the 4th power. And it stays on top. Now the reason why is because the 5, there's more on the top. Basically, what happened was you had 5 x's on the top divided by 1x on the bottom. You see? And then this cancels out this, so you're left with x4 on the top part. All right. So now let's move here. Now look, we have a double exponent, so we have to multiply these. So y to the 4th divided by y to the 4th equals, now if you want to put a 1 in the front, you can put a 1 in the front. But if it's the exact same thing, this is just going to be 1. Remember, when something is dividing itself, it's just equal to 1. Okay? Now the negative exponent rule is probably the hardest one. So whenever you see a negative exponent, there has to be some type of a, let's like call it a flip. So you would put it like this, like in a fraction form, and then it's going to flip to the bottom, and then it turns positive, like that. All right, so what I mean by that is, let's put like a fraction here with the 1 on the bottom. Remember, just make a fraction. So this part that has a negative exponent has to go to the bottom. So on the top, I still have this negative 5 chilling, and then this x squared becomes positive. So you have to be able just to kind of like flip it around. So for example, all right, 4 divided by 8, if you put that in the calculator, you're going to get 1, 2. Right? Now, if I do my rule, like the quotient rule before, 2 minus 5, because remember, you get the top number minus the bottom number, I'm going to have k to the negative 3. So now I have to flip, because this is a negative exponent, it has to go to the bottom. So 1/2 and then k positive 3. All right. And it kind of makes sense, because look, watch. I like to, like, if I were to expand it, you would have 2 k's on the top, 5 k's on the bottom. Who has more? The bottom. It has 3 more. So you can kind of skip the step if you want to expand it, but the rule is always going to be right. All right. Now this is the easiest one. Anything raised to the 1, sorry, anything raised to the 0 equals 1. You can have whatever you want on the base. As long as there's a 0, it's going to equal 1. So right here, this is going to be 7. And then this is going to be a 1, this turns into a 1 because x to the 0 is 1. What is 7 times 1? 7. All right. So here I have 4 times 2. That's going to be W8 divided by W8. Well, according to the rule, I'm supposed to subtract. What is it? 8 minus 8? That's W to the 0, which means anything that has a 0 in it is going to be 1. All right. So this is the nicest rule. Because we have a 0, if we see a 0, and whatever the base is, like you can have on the star test, I remember there was something like this. Put like little star right here. Bum, bum, bum. They had like 5w squared y divided by 3w squared y to the third. All of this stuff, and then it had a little 0. So it wanted you to confuse you, but when you see this, it's just going to be 1. There's always one on the star test like that. So hopefully we'll keep it. All right.